High on Life 2 is finally here from Squanch Games. It's running on Unreal Engine 5.4, but despite the modern tech, the optimization is frankly atrocious. And let's be clear, this isn't just the Unreal Engine 5 problem. The engine is a tool, and how it actually performs falls squarely on the devs. Most of the massive performance gaps are driven by Global Illumination, where Lumen and Nanite combine into a serious resource hog. Frame delivery is also incredibly inconsistent, but I found a specific fix for the stutters that I'll show you in a bit. Visually, the game has some major issues. The shadows are low res and noisy in distance, popping in awkwardly as you move. The color grading is also completely off, and the texture load-ins are frustratingly slow. On top of that, there's just way too much post-processing cluttering the screen. So I'll show you how to strip back those effects and clean up the image later in the video. But first, let's look at the graphics presets and see exactly how much performance we can actually claw back. Starting with the presets, very high is our baseline at 60 FPS. Dropping to high brings us to 71 FPS, an 18% uplift with almost no visual change. The real jump is at medium, hitting 96 FPS, that's a massive 60% boost, and where the game finally starts to feel fluid. Low reaches 109 FPS, an 82% gain, but it looks significantly worse. So this honestly is already looking pretty rough, considering I'm testing this on an RTX 5080 at 2K ultra wide resolution with DLAA enabled. Next is view distance. Usually this is a key setting for managing CPU overhead, but in High on Life 2 it's essentially a dead slider. I've tested the range from low to very high and found zero performance delta and no discernible change to the level of detail. Since the game relies so heavily on Nanite, the engine manages geometric streaming automatically, rendering this traditional setting redundant. So because of that, it really doesn't matter which setting you use, it provides no visual gain and consumes no extra resources. Next is Global Illumination, which manages both bounce lighting and lumen reflections. In this example, we're gonna look at GI first. Dropping to high gives us an 8% uplift over the baseline, with only a minor reduction in ambient occlusion. However, moving to medium provides a massive 40% jump in performance because the game disables lumen entirely and falls back to SSGI. This significantly changes the game's appearance, making the lighting look much flatter and less dynamic. So unless you're strictly prioritizing performance, high is the recommended floor to keep the intended visual depth. Looking closer at the reflections, this scene proves that lumen is only active on high and above. Dropping from very high to high gives us a 19% uplift, where the reflection resolution and the amount of scene data being tracked are slightly reduced. The real shift happens at medium, with a 51% jump in performance. This is where the game disables lumen reflections entirely, resulting in that much flatter look we discussed. Low offers a negligible 57% total gain, reinforcing that high is the sweet spot if you want to keep the game's lighting intact. Taking a closer look at the difference with lumen off, you can see the game is using standard screen space reflections. The entire museum looks significantly more dull and the lighting feels disconnected from the environment. But as soon as we toggle lumen back on, the scene completely transforms. You get accurate light bounces and ray traced reflections that actually ground the objects in the world. While the performance cost is high, this comparison shows exactly what you're losing. Moving on to anti-aliasing, and the results here depend entirely on which method you choose. If you're using TAA, there is no performance difference across the settings. You should set this to very high as it provides the best edge clarity without any added cost. However, TSR is poorly implemented here. It actually loses performance as you move up the presets, and very high actually looks more aliased than low, with more noticeable stair-stepping on the edges. If you aren't using DLSS or FSR, the best move is to stick with TAA very high or TSR low for the cleanest image. Shifting focus to shadow quality, the performance story remains the same. The impact is almost non-existent. Whether you're on low or the very high baseline, your frame rate stays almost identical, making this a purely visual choice. The primary change here is how the engine filters shadow edges. While medium introduces some initial softening, you really need high or very high to get a consistent, realistic fall off across the entire scene. Notice the difference in the shadow cast by the lamp next to the palm tree. So since it's basically a free visual upgrade, leave this on very high. Turning to post-processing, this is a setting where the high presets actually make the game look worse by adding a heavy layer of blur. On low and medium, that filter is removed, but you lose almost all the depth because the ambient occlusion becomes incredibly weak. Since the performance cost is essentially identical across all settings, the best move is to keep this on very high to retain the strong ambient occlusion, and then manually remove the blur. I've actually got an ini file fixed to strip that blurring out while keeping the depth intact, which I'll show you right after this comparison. So to get the best of both worlds, strong ambient occlusion without the forced blur, we need to create a custom Engine.ini file from scratch. First, navigate to your local app data folder. For Steam users, you'll find the directory right here. Instead of just typing %appdata %, you can also type in %localappdata% right away. I've also included the specific path for the Microsoft Store and Game Pass versions in the description box below. Since the file doesn't exist by default, right-click in that folder, select New, and then Text Document, or just open Notepad or Notepad++ just like me and then add it in the folder. Name it exactly Engine.ini. If your Windows isn't showing file extensions, make sure the icon changes to a configuration file and doesn't stay as a text icon. Open that new file with Notepad or Notepad++, paste in the lines of code I've provided in the description box, and hit save. And one final important step, right-click on your new Engine.ini file, go to Properties, and check the read-only box before hitting apply. This prevents the game from overwriting your changes and re-adding the blur later on. When it comes to texture quality, this doesn't actually change the resolution of the assets. It just changes how they stream in. If you watch as I walk toward the sign, you'll see that on high and very high, the sharp version of the textures load in just a fraction of a second faster. Though the difference is honestly minor. Performance is virtually identical across the board. High on Life 2 is extremely memory hungry, and 8GB cards will choke on the higher presets. To keep your frame times consistent and avoid those hitches, I recommend sticking to low or medium. You aren't losing any actual detail and it keeps the game running much smoother. When we look at effects quality, we finally see a setting that actually offers some meaningful performance gains aside GI. The main visual difference here is in the particle density when you're firing your weapons. Higher settings give you more debris and sparks, but in the heat of combat, it's something you'll rarely notice. Compared to our very high baseline, dropping to medium gives you a 10% performance boost, and going all the way to low gains you a 12.5%. Given how fast-paced this game is, I recommend sticking to low or medium. The extra frames are worth way more than a few extra sparks on the screen. Next up is Foliage Quality. You'll notice that changing the setting does, well, absolutely nothing. The visuals remain identical and the performance is completely flat across every preset. This is a classic characteristic of Nanite in Unreal Engine 5.4. Since Nanite virtualizes the geometry and scales detail automatically based on your screen resolution, traditional foliage presets for distance and detail become redundant. The engine is already rendering the most efficient version of the greenery possible, so you can leave this on very high. Not because it looks better, but because it doesn't cost you a single frame to do so. And for last, we have to address the biggest issue in High on Life 2, the unstable frame pacing. Even if you use the in-game FPS cap, you'll notice the game feels micro-stuttery. This is because the built-in limiter is imprecise, delivering frames at uneven intervals. And unfortunately, VRR like G-Sync or FreeSync won't save you here. Even with G-Sync disabled in my test, the jitter remained. The only real solution is to use Riva Tuner Statistics Server, short for RTSS, which comes bundled with MSI Afterburner. By capping your framerate through RTSS instead of the game, you force a busy wait loop that ensures every single frame is delivered at the exact same interval. This is especially vital if you're using frame generation, which almost is mandatory in this game sadly, as any pacing issues are doubled when the AI tries to interpolate between jittery base frames. Turn off the in-game cap, set your limit in RTSS, and the game will finally feel as smooth as it looks. And just to clarify, this issue also persists if you run the game completely uncapped, as maxing out your GPU leaves no room to smooth out engine hitches. To fix the frame pacing, open up Riva Tuner's Statistics Server. Look for the frame rate limit box on the right side of the interface. Click into it and type the value you want to lock the game to. Just remember to pick a number that your PC can hit consistently to maintain that GPU headroom. Once you hit enter, you'll see the limit active in the profile list. You can also toggle the on-screen display here if you want to monitor your frame time graph while playing. With this set, RTSS now handles the frame scheduling, giving you a perfectly smooth flat line. So as you can see, you can't really squeeze massive gains out of this game unless you sacrifice Lumen by dropping Global Illumination to medium or below. That should be your absolute last resort, only do it if you can hit a base 60 FPS. Hitting that 60 FPS target is the magic number, because it allows you to engage frame generation to hit a buttery smooth 120 FPS with an RTSS cap. Now don't get me wrong, I'm a huge fan of frame generation, but it shouldn't be a crutch to get you from 30 to 60. That just isn't a viable way to play. It's a blessing when your base frame rate is already solid and you just want to max out your high refresh rate monitor or TV. So yeah, stick to the following settings, lock your pacing, and enjoy the game the way it was meant to be played.
You're kidding, right?
Maybe we need to come back here later?
If this guide helped you fix your stutters or get the game looking sharp, drop a like and consider subscribing for more deep dives into Unreal Engine optimizations. Don't forget to check the description for those Engine.ini path and the code blocks. Thanks for watching, and I'll see you guys in the next one.